Well, if you're like me, you haven't dealt with coordinate systems in quite some time. And the reason for that is because GIS packages do a really good job in managing coordinate systems and allowing us to mix data with different coordinate systems. So for instance, we can have data that is, say, in Universal Transverse Mercator, and we can overlay that with data that's in latitude and longitude WGS 84, and there's no problem. Well, in the spatial database world, there's a problem. We do want these data to have the same underlying coordinate system. So what you're going to see happening with Postgres and even with SQL Server and Oracle as well, they're all dealing with it at that base level, and they're not performing these coordinate transformations on the fly. So what we're going to use is something called an SRID. And an SRID is a spatial reference system identifier. So this is a way to provide a value that unambiguously identifies a projected, unprojected, or local spatial coordinate system. QGIS does a pretty good job of dealing with spatial reference systems. Let me just right click on the flood zones, and I'll say let's any one of these. Let's set the layer CRS, coordinate reference system. So here's where I can type in SRIDs. They're also known as EPSG. And an EPSG stands for the European Petroleum Survey Group. They pretty much follow the same names as the SRID. So when I come in here and I look at the coordinate system, I'm not going to change anything, but I can type something like, we can see here, Maryland. Okay, that's NAD 83, Maryland coordinate system. And these are all the different types. North American Datum 27, North American Datum 83, and you can see through here all the different kind of coordinate systems that are available and their EPSG code that are in here. Let's put in universal, spell it right. I should type in UTM. So that's the Universal Transverse Mercator coordinate system, and we have a whole bunch of them. So here's UTM zone 18, because that's where the Tompkins County data is in. So Universal Transverse Mercator, this is what's really nice about QGIS. It shows us how that is represented. So in this case, UTM zone 18 is EPSG 32618, and that would be the SRID as well. Let's look at New York Central. So this is one I've used previously, but there's a number of different New York Central coordinate systems. Here's the NAD 27, here's the NAD 83, here it is in feet, and we have it in meters. So 2261 is the New York Central State Plane Coordinate System in feet. And then let's look at one other one, latitude, or WGS 84. So that is 4326. That's the World Geodetic System of 1984. There's one for 1966. There's one for 1972. You have all the other parameters here related to ellipsoidal parameters. There's also a World Mercator that we just scrolled by. So you can see a lot of different coordinate systems. This is one you're going to probably want to memorize. 4326 is our standard latitude and longitude coordinate system. So what does this mean? Well, let's look at our states data. Here I'm going to say select the ST_SRID from states. And as I do that, that's 2796. 2796. That's using the Lambert conformal coordinate system, using NAD 83, HARN, and the Kansas system as its center. So some of the things we can do is define a projection and also change a projection. We just selected the projection to see what the number was. If I wanted to actually update the geometry SRID, we can do that by saying select update geometry SRID states, and then the column name geom, and then I give it a brand new projection. Now this is like anything you've dealt with GIS before too. There's a really good way to really screw this up when you don't get these when you don't understand what these are. So let's say select st underscore srid of the geom from the states. So let's look at that. 2796. So let's type in, copy this, and let's put this in here. And let's turn it into 4326. We talked about that before with the coordinate system for latitude and longitude. And we'll run this. Okay. And that's done. So let's say select star from states. What this did was it now assigned the latitude and longitude coordinate system to the states. Let's run this. There it is, and let's take a look at our geometry. Oh, that's messed up. That's totally messed up, and the reason is we did not change the geometries. We took data that was in that Lambert conformal system and told it, no, it's really in latitude and longitude. So bad job. Now we have to go change that, 2796. Now we're going to change it again, and then let's run it, and let's take a look at our data. And now we're back in the same place. Now, this is what it looks like. Now, we don't see anything behind here, and the reason is pgadmin 4 is going to require you to have it in latitude and longitude before we're able to look at the data with a background for like the OpenStreetMap background. I'm expecting this is going to change in the next year. More and more people are going to ask that that we look at the coordinate system we're working in and actually change the background. But at the moment, it's not doing that. So let's say select ST transform geom 4326 from states. Now the cool thing is what we learned before is if I look at the SRID from the states, it knows what coordinate system it's in right now. So I'm saying I want you to transform and I want you to physically move the geometries from one coordinate system to the other one. And we'll do that. That's done. And now we have the latitude and longitude. Notice we don't have that curve any longer, right? Because we're in latitude and longitude. So the top of the US is this straight line. But the nice thing is it does fit on top of the United States. Now I'm going to look at the last spring frost data that we have. And this is 4030. So I can write some kind of a query that says select star from, let's say select states dot star from states LSF where ST contains states.geom and lsf.geom. So let's run that. Okay, this is a problem. It says operation on mixed geometries. That's not allowed. So what we have to do is transform the last spring frost date, st underscore transform, and we can say 2796. And we have to put a separate parenthesis. So let's run that. And now it's selected those states that are part of or that have the last spring frost date inside them. And these are the ones. So it's the southeast US. Now I can also say this, select st transform states.geom 4326. So I'll transform that on the fly. So this has transformed the last spring frost date on the fly into the same coordinate system as the states so we could perform this ST contains. Now this is the result of those states that were selected, but the problem is it's not in latitude and longitude, so I'm going to do that right now. So let's run that. There we go, and we can take a look at that. And now you can see the states that are part of, that have those last spring frost dates. We can say here, select star from last spring frost date. So these are the actual records of last spring frost date, and you can see where they are. This is down in Florida. And again, we can do the same thing as before, st underscore transform geom 4326. Let's run that. And we'll take a look at it. So here's these last spring frost dates that, and we'll look at that a little later again to do some more analysis with it. But that gives you an idea of where they're located, and now you can understand why this command will select only those states that are in the southeast section or portion of the United States. So we're going to move on to all the other kinds of spatial commands, but right now I did want to show you the coordinate system because it's so fundamental to what we're doing. And again, it's very, very important in something like Postgres that we have our coordinate systems matching. Otherwise, we're going to get errors. So I wanted you to see the difference between finding the SRID to updating an SRID to transforming an SRID. And this is again the same problem we have in GIS. If you think in like the ESRI world, there's the set projection. Excuse me, I mean the define projection versus the project command. So project will actually move and change the data just like st-transform does, and the define projection just says let's assume that the projection for this data is latitude and longitude or UTM. So that's the same for update geometry SRID.